So what Euler did, simple, whatever may be the motion, okay, whatever may be the motion of a rigid body, he said that that particular body is going to undergo rotation. Okay, it may be combination of pure rotation plus translation, but that body is going to undergo pure rotation about one particular point, and that point is called as instantaneous center, or center of instantaneous center, or center of instantaneous rotation. Okay, right, or simply I center. Okay, simply I center. And how did he prove that? He used some technique of geometry, and then by drawing a perpendicular bisector, and then the point at which the perpendicular bisector intersecting is the I center. And by using the equidistant principle, we drawn the circle, and from that I said that each and every point, suppose this is the rigid body, if it undergoes general motion like this, okay, general motion like this, it will be general motion. But even though it is general motion, at some particular point, okay, at some particular point, about this point, this will be rotating. Okay, about this point, it will be undergoing pure rotation. So if I'm not keeping this point as my reference, it's undergoing some general motion only. But now by keeping this point as reference, about this point, it is undergoing pure rotation. So each and every point will undergo pure rotation. That is what Euler said. And once, if the rotations, like once the motion happens, for example, at some instant, okay, at some instant, it's undergoing some translation plus rotation. Of course, it's undergoing some general motion. Let us imagine it reached this position. Okay, it reached this position. Okay, this is A dash, this is B dash. And let us consider that instantaneous center. Again, by joining this two, if I draw the perpendicular bisector, we will get instantaneous center somewhere here. Okay, so this is instantaneous center during this instant. Okay, during this instant means for a very small time, delta t, how much distance this has moved. See, you might ask me a question, sir, how this AB is moving that much distance for a very small time delta t? See, honestly, it will undergo very small motion only, something like this. Okay, something like this, very small motion only. But if I show you that very small displacement in the board, obviously we cannot do the analysis, you won't able to understand, or even I won't able to draw the diagram properly. Okay, so this is an exaggerated look. Okay, so actual at very small time delta t, that is at some instant of time, it is just moving. Okay, it is just moving, but when it is moving, it is undergoing rotation plus translation, that is, it is undergoing some general motion. And during that instant, we are getting instantaneous center I here. Now let us consider further at the next instant. Okay, for the next time delta t, this is moving like this. Okay, this is moving like this. This is moving like this. Let us consider it is moving like that. So again, we will be getting something like this, right? We'll be getting something like this, and this is going to be B double dash. This is going to be A double dash. And now you can find out instantaneous center for this again by joining this two. By joining this two, you find out the perpendicular bisector. By joining this, I will get a perpendicular bisector. By joining this, I will get a perpendicular bisector. Let us consider this is our I. Okay, so this is our instantaneous center during this motion. Okay, when this rigid body is moving like this at some instant. Now in the next instant, okay, for the next delta t, this rigid body is moving like this. Okay, this rigid body is moving like this. Now I am finding instantaneous center. Instantaneous center means what? A point about which the rigid body is rotating, right? So this I, we will take it as I2. So this is instantaneous center during this, okay, during this motion. And now again, let us consider this. This is further moving, and let us consider it is reaching somewhere here. Okay, it is further moving. Okay, it is further moving, and it is reaching like this. Okay, it's further moving, and it is reaching like this. Okay. Now this is A triple dash and B triple dash, and again you plot the, plot the graph, and we will find out this is going to be our I3. I'm just assuming it. Okay, I'm just assuming it I1, I2, I3, and this is I3 is the instantaneous center during this instant. That is when A double dash and B double dash rotating, right? That is A double dash, B double dash. It's not rotating actually. It's undergoing translation plus rotation, but it is rotating about I3. Okay, so that is what Euler is doing. So this is rotating about I3. So now what you are able to identify? Simple. We are able to find out that when the position of this AB changes, okay, that is at each and every instant when the time changes from delta t to 2 delta t or 3 delta t. Initially for a very small time delta t, I got this instantaneous center. When this changes like that, I'm getting new instantaneous center. When it changes further, I'm getting new instantaneous center. So this instantaneous center or center of instantaneous rotation is not fixed. It will vary and it is fixed for an instant only. Okay, at a starting instant we are getting this. The next instant it moved there, and the next instant it moved there. That is why the name instantaneous. Okay, instantaneous. For an instant I will be constant, but if time changes, I will be keep on changing. Okay, I hope it is clear. So that is why the name instantaneous center or center of instantaneous rotation. And now if I join this, okay, or if I trace the path, which means if I find out the locus of, okay, if I find out the locus, I hope you know what is mean by locus. Let me draw it properly. Yeah, if you find out the locus, of this instantaneous center, locus means what? I'm just tracing the path, okay, tracing the path of this instantaneous center. During first instant, I'm getting this I1, right? As it is keep on moving, as this A dash, B dash keep on moving, this instantaneous center is also keep on moving, and it is reaching there when it reaches A double dash, B dash. And similarly, this A double dash, B dash keep on moving to A triple dash, B triple dash. This instantaneous center is also keep on moving, and it is reaching I3. So instantaneous center will keep on varying as the body continuously moves. That is, for each instant there will be different instantaneous center. And if I start finding out the locus, or if I start tracing the path, and that path is called as centroid. Okay, that path is called as centroid. Okay, so centroid is simply locus of instantaneous center, or just you are going to trace the path of instantaneous center. Okay, so let us proceed discussing instantaneous center. So here I'm going to discuss, or I'm going to give you the first idea or the first method by which we can easily find out the instantaneous center, and then we can solve the problems. And we will discuss one by one. So this is the first method. Okay, we know that if suppose I take, this is my body, okay, that is my rigid body. Let us take the same example. Okay, this is my rigid body. It is undergoing some general motion. Okay, if it is undergoing some general motion, what you will have said? You will have said that let it undergo general motion, but each and every point in the body has to undergo pure rotation at some common point. Okay, and that point is called as instantaneous center. And as the time changes, that is at each instant, that instantaneous center will also vary. Okay, now at some particular instant, this body, rigid body, has to rotate about one point, right? That is nothing but what? Instantaneous center, right? I. Instantaneous center, right? I. So what I will do, I will take only this particle or this point A. Okay, this point A is also rotating about instantaneous center I. This point B is also rotating about instantaneous center I. Similarly, if I take any point, okay, if I take C here, that point C is also rotating about this instantaneous center I. Let me first take this A point. Okay, so let us consider A point is rotating like this. Just consider that it is a circle. I am not drawing it as a circular. Yeah, so this is point A. Okay, this is point A. It is rotating about instantaneous center I. We know that if pure rotation, so if it is pure rotation means what? Point A is undergoing circular motion. If it is undergoing circular motion, then how many velocities will we have? We will have only one velocity, and that velocity will be always tangential. Tangential means what? Tangential means it will be perpendicular to the radius. It will be perpendicular to the radial distance, and that is, it will be something as we are considering that it is rotating like this. Okay, we are considering that it is moving like this, so it is rotating like this. So my tangential velocity VA, okay, will be equal to R into omega. Radius is this distance, right? Distance from A to I. Okay, this has to be perpendicular because tangential means it has to be perpendicular to the radius. So radius means AI into omega. That is something which you need to note now. Omega is what? Angular velocity. And which angular velocity I need to take? Listen carefully. This is a rigid body undergoing pure rotation. So if I take any point in the rigid body, as we already discussed, if we take any point in the rigid body, now we are assuming that it is undergoing pure rotation only, right? So you take any point on the rigid body, the angular velocity has to be same only. or even that is also fine. Or else you imagine like this. This is a body, it is undergoing some motion, okay, some rotation. Obviously it is not rotating like this, okay, it is not rotating like this, or it is not rotating in this manner also, okay, it is not rotating in this manner also. It's a planar motion, so only one motion will be there, only one type of rotation will be there. That is going to be rotation which is going to happen in this plane. There is no possibility for rotation in this plane or in the top and the bottom plane also. Okay, so only one rotation possible. So on that we are going to assume that it's going to be omega AB. Okay, so just keep this in mind. We are considering planar motion only. So in a planar motion, a body can rotate or the angular velocity can be only one. Okay, there cannot be two angular velocities. There cannot be angular velocity in this direction, or there cannot be an angular velocity like this. Only one angular velocity, which is omega AB. So each and every particle or each and every point in this rigid body will undergo angular velocity of omega. Okay, omega AB. Okay, so again, let us come back here. For a circular motion, we will have only tangential velocity VA. Since it is tangential velocity, it has to be perpendicular to the radius. So VA will be equal to the radial distance into angular velocity. So that angular velocity here was omega AB. Okay, so this is our tangential velocity, or only one velocity will be there. Okay, that is going to be velocity of point A. Okay. What about velocity of point B? Again, point B is also, let me just show you that separately. Okay, point B, again consider it to be a circle. Okay, I'm not drawing it as perfectly circle, but yeah. So let us consider this is point B, and let us consider this is the instantaneous center. So point B is also undergoing circular motion only, because point B is undergoing pure rotation about I, right? So point B is also undergoing circular motion only. So it has only one component of velocity, tangential component of velocity, and that will be equal to again R into omega. What is the radial distance here? BI, right? Radial distance is BI. Okay, BI into omega AB again. Okay, so this is velocity, tangential velocity at point B. Now, as we know already, this rigid body is rotating at an angular velocity omega AB. So this omega AB and this omega AB will be same. So what I can do, I can write like this: omega AB will be equal to VA by AI. Similarly, from this equation, okay, from this equation I can write omega AB is equal to VB by BI. So what is the final conclusion I can give? VA by AI is equal to VB by BI, which is equal to omega AB. This is a very important equation, and we will be using this equation repeatedly for solving the problem. Listen carefully. Point A, point B is fine. If suppose there is another point C, I'm going to take point C. What I will do? Simple again, find out the distance between C and I. Okay, C and I. So it will become VC by CI. If I take point D, find out distance between D and I. Okay, and the equation will be VD by DI. Okay, so VA by AI will be equal to VB by BI, which is equal to VC by CI, which is equal to VD by DI, and all these things will be equal to the angular velocity of that particular rigid body. Okay, right. Now I hope that until this it is clear. Now very important point. Okay, again this point will also be very useful when you are solving problem. Let us consider like this. Let us consider there is a rigid body here. Okay, and how they will give in the problems. Okay, the first method, okay, to identify or to find out this I center. Okay, how to find out that? They will give the rigid body, and also they will be giving you the, what is that? They will be giving you the direction of velocity. Okay, let it be B, and they stated that this is the direction of velocity. Let it be. Okay, and also they said that also they said that this is let this be the direction of VA. Okay, this is point A. Okay, this is point A. Okay, this is point B, and they said that point B, a direction of velocity was like this. That is only tangential velocity, obviously. So this is the tangential velocity VB, and point A, this is the tangential velocity VA. Now, how to find out I center? Very simple and straightforward. I repeatedly said this also. That is why I repeatedly said this. When a particle is undergoing circular motion about instantaneous center or about any point, that particle or that point will undergo only, like that point will have only tangential velocity, and that tangential velocity will be perpendicular to the radial distance. Okay, so that is perpendicular to the line. In other word, perpendicular to the radial distance. In other word, what I could say, this line is nothing but the line which is having instantaneous center, right? If I draw something like this, okay, if I draw something like this, here it has to be, the velocity at point A has to be tangential, which means it should be like this. Am I right? And similarly, velocity at this point should be tangential, which means it should be like this. Okay, so this is velocity at B, this is velocity at A. So what does it mean? Velocity at point A, okay, velocity at any point, that velocity should be perpendicular to the line joining that point and instantaneous center. Why? Because that velocity will be tangential, right? Then only it will be tangential. If I draw a circle, okay, if I draw a circle like this, then only it will be tangential. So when velocity will be tangential to the circle which I am drawing about by taking I as center, one and only if this velocity is perpendicular to the line joining that point and I center. Okay, so that is, I repeatedly said this when I am beginning, right? So this tangential velocity at point A has to be perpendicular to this line AI. Okay, why it is perpendicular to the line AI? Because only one velocity, tangential velocity. So tangential velocity will be always perpendicular to the radial distance. Okay, so what is the point? What is the observation which we are making here? Simple. Velocity, that is tangential velocity, should be always perpendicular to line joining the point. Okay, the point about which I am going to find out the velocity. So line joining the point and instantaneous center. Okay. So by using this conclusion, how can I find out instantaneous center? Simple, very simple. They given velocity, okay, they given velocity. Then instantaneous center is going to surely lie in the line which is perpendicular to velocity, right? Just see that example. They given the direction of velocity. Let us consider for maybe they would have given magnitude or they would have not. But they given, so magnitude they would have given, they would have not given, but they given the direction of velocity, right? They given the direction of velocity. So this is the direction of velocity. And now what is the point which I got? I got the point that instantaneous center will lie in the line which is perpendicular to the tangential velocity. So simply draw a line which is going to be perpendicular to this velocity first. Let me draw it. Okay. Yeah. So this, let us consider that it is perpendicular to VA. So now I know that instantaneous center is going to lie in this line. Okay, it's going to lie in this line, but exact point I don't know. Exact point I don't know. And what is another thing which I have? I have VB, and we know again instantaneous center is going to lie in the line which is perpendicular to VB, because VB is a tangential velocity. So instantaneous center has to lie in the line perpendicular to it. So if I draw a perpendicular to this point for this velocity, okay, for this velocity I am drawing a perpendicular line. Okay, so this is perpendicular line. Okay, so this is n and this is m. Okay, so m is perpendicular to this velocity VA, or let me not mention it with any name, just leave it. Okay, so this line, okay, this line is perpendicular to velocity VA. This line is perpendicular to velocity VB. Now listen. We know that instantaneous center I, okay, has to present in the line which is perpendicular to VA. And also it has to present in the line which is perpendicular to VB. What does it mean? It clearly means that there is only one possibility, that is at point of intersection. Okay, only at point of intersection only at point of intersection we will be getting instantaneous center. Okay, why? Because instantaneous center should lie in this line also, that is line which is perpendicular to VA. Instantaneous center should lie in perpendicular to this this velocity VB also, that is this line also. So what is the only possibility? Only possibility is at the intersection. Okay, at the intersection. So this is our instantaneous center. This is how you need to find. So very simple. How you will find? They will be giving you, okay, if they are giving you the velocity direction, simply draw a perpendicular line, okay, to the top this velocity, and also draw a perpendicular line to the top this velocity. Wherever it is intersecting, that is your instantaneous center. Draw perpendicular to the velocity vectors. Wherever it is intersecting, that is your instantaneous center. You might have learned this also already when you are doing some problems before, if you are learned engineering mechanics, but how it comes, That is something which we understood in this video. So how we are taking that as instantaneous center? The very simple reason is point A or point B both are undergoing circular motion. So if it is undergoing circular motion about I center, okay, it is undergoing circular motion about I center. So if it is undergoing circular motion about I center, then it has only one velocity component, that is tangential velocity, and that tangential velocity will be perpendicular to the radial distance. Radial distance means here the distance is a distance between the point and the instantaneous center. That's it. Okay, so this is how you need to find out geometrically. This is the first method. Now coming to problem, what they will do. See, from this equation I can find out, right? This AB is rotating with an angular velocity omega AB, let it be. So I can easily say that, I can easily use this formula, right? I can use this formula which we got just now. Okay, what do we got? VA by AI, right? VA, this distance is AI, right? You could see. I will just show you. Yeah, this distance is AI. Okay, VA by AI, and similarly VB by BI. Okay, that will be equal to omega AB. Now, by geometry, you will be able to find out this AI and BI. Okay, by geometry, by Pythagoras theorem and basic geometry, trigonometry, we can find out AI and BI. And the unknowns are VA, VB and omega AB. This is one possibility. Okay, VA, VB and omega AB. So what they will do, they will give one value of velocity. For example, they will give VA. Okay, they will give VA to you, and they will ask you to find out VB, or they will ask you to find out omega AB. So if you are able to find out AI and BI, okay, by geometry, I can simply use this formula, I can find out. Or else they will give some difficulty in finding out I. Okay, instead of that, they will give you VA and VB. Okay, both velocities will be there. Now by using these velocities, I need to find out this distance AI and BI, and I need to proceed solving. So once we deal with the numericals, you will understand it. Okay, so simply what they will do, they will give some terms which you know, and there will be some terms which you don't know. So by combining those two, you need to find out the unknowns. That is what it's going to be. So you will solve some numericals now.